Hey, what's going on? Today we're going to be talking about solving systems of equations by substitution. Now, the important thing to know about solving by substitution is that it takes advantage of what it means for two things to be equal. You see, when two things are equal to each other, it means that even though they might look different, they have the same value, which means that it's perfectly legal for us to replace one for the other. It's like synonyms in your English class, but you didn't come here for no English lesson, and you probably don't care too much about what it means for two things to be equal. This video is meant to teach you how to solve by substitution, so let's dig down here and see what we're supposed to do. Right, the steps are up here on the screen. To solve a system by substitution, step 1, you're going to solve one of your two equations for one of the two variables in the equation. Don't matter which one you pick, just pick one and stick with it. That don't mean you can't make the work a little easier for yourself. We're going to be on the lookout for some of these characteristics when we do the examples later, but it's hard to mess up the choice. Like I said, just pick something and follow your heart. Once you have solved one of your two equations for one of the two variables in the equation, you're going to replace that variable in the other equation with the expression you found in step 1. Then you're going to simplify, and that's going to allow you to solve for one of your two variables. Finally, you're going to take the number answer that you got at the end of step 2 and plug in for that variable into the equation that you found in step 1. And then you're going to have an answer for both variables and, by extension, an answer for the whole problem. You got all that yet? No, of course you haven't, because you haven't seen this done out yet, so why are you thinking that you should get it just by hearing the steps? Let's go ahead and shut our yaps and take a look at a couple examples so we can get a sense of what's going on. Our first example is 2x plus y equals 9 and negative 3x plus 4y equals 58, and we want to solve this system. If we're going to solve by substitution, we got to pick one of the four variables that we have here and solve its equation for it. Now, which one is the right choice? Your best bet is always to pick a variable that's all by itself, that's either just x or just y. And if that doesn't exist in either one of your two equations, then pick the one that has the smallest positive number in front of it. Lucky for us, as you can see here, we have a y all by itself in the first equation. So we're going to solve the first equation for y. So we write it down, 2x plus y equals 9, and we got to get y by itself. So we minus our 2x from both sides here because it's being added to the y, and that's going to give us a solution here, something that we could substitute into the other equation. Y equals negative 2x plus 9. So we go ahead and take this expression negative 2x plus 9, and we're going to plug it into our second equation for y right here. Let's make that happen. Here goes nothing. So we get negative 3x plus 4, and then we'll put parentheses, and then the expression negative 2x plus 9. See, we just replaced the y with the negative 2x plus 9. Right. Next, we're going to distribute the 4 into the parentheses. This gives us negative 3x plus 4 times negative 2x is negative 8x, and 4 times 9 is going to give us 36. This all equals 58. Combine our like terms. We have a negative 3x with a negative 8x to give us negative 11x, plus 36 equals 58. Now solve for x. Minus 36 from both sides. These 36's cancel out. 58 minus 36 is going to equal 22. And then we need to divide both sides by the negative 11 to get x all by itself, which gives us x is equal to negative 2. This is half the information we need for our final answer here, so we're going to take this negative 2 and plug it in for x into the equation we found in step 1, and that's going to give us our y value. Let's put our money where our mouths are. Y is equal to negative 2 times negative 2, the value we just found, plus 9. 2 times 2 is 4. Negative times negative is positive. We add that to the 9, and that's going to give us our y value of 13. So we have an x value. We have a y value over here. Our final answer is going to be the points negative 2, comma 13. That's it. Hopefully this is starting to make a little bit of sense to you, but of course more examples will provide more clarity, so let's move on to the next one. Our next example is negative 8x plus 2y equals 6 and x minus 5y equals 4. See how the x is all by itself over here in the second equation? That's a telltale sign that that's the variable that we want to solve for. So we're going to take the x minus 5y equals 4 and solve for x. We're going to add 5y to both sides, and that's going to get x all by itself. And this is going to give us the equation x is equal to 5y plus 4. Great, so that's our step 1. Now step 2 says take this 5y plus 4 and plug it in for x into the first equation right here. Then we'll simplify, solve, and replace again, and that's going to get us the rest of our answer. But let's not get too far ahead of ourselves here. We have negative 8, and then we're replacing x with 5y plus 4, plus the 2y is equal to 6. Distribute the negative 8. Negative 8 times 5y is negative 40y. Negative 8 times 4 is negative 32. Plus 2y is equal to 6. We're going to combine our like terms here. We have the negative 40y and the 2y. That gives us negative 38y. Minus 32 is equal to 6. Add 32 to both sides. Now we're trying to solve for y, right? That's going to cancel out the 32's over here. We get negative 38y equals 32 and 6 together is 38. Now we got to divide by that negative 38 in front of the y because it's being multiplied, right? When we do our division, this is going to give us an answer of y equals negative 1. All right, half the information for our answer. Let's take this negative 1 right here, plug it into this equation over here, and that's going to get us the rest of our answer. So here goes nothing. We're going to get x is equal to 5. We're plugging in that negative 1 for y, and then we have plus 4. 5 times negative 1 is equal to negative 5 plus 4. We add those two together, and that's going to give us an x of negative 1 as well. We have a y value. We have an x value. So we can make a point for our final answer. X was negative 1, y was negative 1, and our answer is negative 1, negative 1. Once again, that process is solve, substitute, solve, substitute. Let's look at one last example that's going to be a little bit more involved. In this last example, we could see here that neither one of our two equations has just x or just y in it. And I told you before that if you need to make a choice, pick the one with the smallest positive number in front of it. So we are going to solve this first equation for x since it has the smallest positive number, 3. We have 3x minus 2y equals 10. We're going to start by adding 2y to both sides here. And that's going to give us 3x is equal to, ready for this, 2y plus 10. How groundbreaking. Now we need to get that x by itself, so we're going to divide everything by 3. And this is going to give us a final expression here, for now anyway, of x is equal to 2/3 y plus 10/3. Leave things as fractions most of the time. It's going to make your answers more precise. And now we have the unique joy of plugging this thing in to our x in the second equation right here. It seems like it's going to be a drag, but trust me, it's not nearly as bad as it seems. We get negative 6. The expression again was 2/3 y plus 10/3. And then we need the rest of our original equation here. So plus 7y is equal to negative 11. We distribute. If you're going to do a whole number times a fraction, divide by the bottom and then multiply by the top. 6 divided by 3 is 2, times 2 is 4, positive times negative is negative. 6 divided by 3 is 2, times 10 is 20, positive times negative is negative again, and then the rest of our equation. Combine our like terms. 7 minus 4 is 3y. Minus 20 is equal to negative 11. And now we solve for y. Add 20 to both sides, and that's going to give us 3y is equal to 9. Now we divide both sides by 3 to get the y by itself, and we get the very nice answer of y is equal to 3. And to get our x value, we're going to take this 3 that we just got here, and we're going to plug it into the equation we found in step 1 right here. We're still going to have to deal with fractions, but hey, that's a fact of life, alright? And as you're going to see in a second, it's really not so bad. We have x is equal to 2/3 times the 3 we just found, plus 10/3. 3 divided by 3 is 1, times 2 is 2, plus 10/3. If we want to add these two things together, we're going to do 2 times the denominator 3, and then add it to the top. 6 plus 10 is 16, so x is equal to 16/3. Here's our y. Here's our x, which means we can give ourselves the coordinate 16/3, 3 for our final answer. Alright, so solving systems by substitution is pretty involved most of the time, but at least the process is going to be the same no matter what. Solve one of your two equations for one of the two variables, plug in that expression for the variable in the other equation, the one you didn't solve for, simplify and solve, and then take the number answer that you got from that and plug it back into the equation you found in the first step. Your final answer is going to be the point whose coordinates are the x and the y value that you found. You want to master this skill? Go out and do your practice like a good little boy or girl. This ain't gonna be one of those things you can just look at and understand. You gotta believe me. Alright? Alright. Later.